My name is Dmitry Polyakovsky. I work at Oracle Cloud, and by the way, we are also hiring. And you can read my blog. If you guys want these slides, there's a bit.ly URL, so feel free to take a photo of this slide, and the GitHub URL will get you the code samples I'll be using for live demo. Let's hope it works, because the last time when I was presenting at a Redis conference in San Francisco, my amazing demo running a Redis cluster with 1,000 nodes crashed literally 5 minutes before my talk. I had a good fallback, but it was slightly deflating. So first, let's do a quick survey. How many people are just getting started with Redis? All right, how many people use Redis for more than a year? 2 plus? 3 plus? All right. So what do you guys use Redis for? Anybody using Redis for caching? Just feel free to shout. Any other tasks, like background job queues, user sessions? Anybody using Redis as a primary database? Oh, you're brave. It is possible, I've done it, but it does require a little bit of work. So the way I think about Redis is a Swiss Army knife. It's good at a variety of things. But just like a Swiss Army knife has a little saw on it, it doesn't mean you shouldn't use that saw to chop down a big tree. So you got to know when not to use such a useful, multi-purpose tool. And in this talk, I'm going to talk about how we can use Redis for data science and data engineering. Anybody doing ETL work, extract, transform, load? Okay. So in Python Pandas, which is a very popular data science library, you frequently code that looks like this. You will import Pandas library, and then you will use methods like read CSV, read JSON, and then you will start doing aggregation. And data frame, that's DF, is essentially equivalent of a SQL table, except it's stored in Python process memory. But you can do aggregations. You can do give me the largest, give me the sum, average, et cetera, et cetera. The problem is that this is a very simple data acquisition process, right? We're reading a file, we're querying a database. And frequently, our data gathering is much more complex. We have to query multiple APIs. We have to query multiple databases. We have to bring all this data together and somehow store it somewhere. And if something fails in this process, let's say one of these tasks times out, we don't want to go all the way to the beginning and start from scratch. So I'm going to do a live demo. And for that, I'm going to use Docker and Docker Compose. Are people familiar with Docker Compose? It's essentially a way to start and stop multiple containers at the same time. So I'm going to start this container. I'm going to actually launch 2 workers, so I have a really scalable environment locally. And here you can see that I have a web container, a worker container, and then I have a Redis container. So total 4 containers in my local setup. And I can see them all running. Great. And my web container is going to expose a couple of things. I'm going to use a Jupyter Notebook. Are people familiar with those? Yeah, great. So it's let's just refresh, make sure this works. Okay. And then I also have on port 5000, I'm going to have this API that I'm going to queue a background job called GitHub. And let's see what it does. So here I have these 2 jobs. One is going to query the GitHub public API endpoint to get all the users, plural. And it looks like this. Okay, so these are all the users. And the second job that I will launch is going to hit each user individual endpoint. And you can see that I have to specify the user login as a unique identifier. And then, as I'm going through all these users, I don't know if you guys ever played with GitHub APIs. These are public, free, but they do throttle you. So you'll use something called GitHub token. I'll show you later what it is. You can actually paginate, except they don't do like start and stop or limit and offset. They have this concept of since. And if I say since equals 0, it's going to give me the very first set of users starting with ID 1. And if I say, see the last ID here is 46. So if I say since 46, the next request is 47. And that's what the background job I'm doing. That's what the background job I'm running right now is doing. It's going to users page. It's bringing back the data. And by the way, Pandas actually has a really nice method called read JSON, and I could have just given it a URL directly, and it would have just grabbed the data and made the HTTP request for me in 1 line of code. But unfortunately, that library doesn't support passing headers for authorization. So, and I have this header that I'm passing as a token. I have a token that I'm passing in a header. So if you're working internally and you're not worried about authorization, for your private APIs, you can actually do it in one line. I had to write 2 lines. So I make a request, grab the data, and then I read into a data frame. And I actually didn't need to use data frame here, but it was easy. And then I loop through the data frame, the rows, the records in there, and I say, okay, now let's queue a background job to grab each user data, specifying the login. So where is the queue? Well, my queue is in Redis. This library I'm using called rqueue uses Redis as a queue, as a place to store. And behind the scenes, it's using Redis lists and a couple of other data structures. Are people familiar with lists? So basically, it's rpush and lpub. But I chose to use this library because I'm lazy. So, I make a request. I queue 30 jobs to get individual users. And at the end, this job queues itself. And I have this counter, so I'm going to make 10 iterations. So I'm going to make 10 requests to the public endpoint to get users. Then each of those requests is going to make queue 30 jobs to queue each user, and so on. So basically, I'm making 310 different HTTP requests. And it's possible that I'll experience a timeout, or there'll be throttling on the GitHub part, and I want to retry something. But I don't want to retry all 310 tasks. I want to be able to retry only one. So then, in the GitHub each user job, again, this is a job that requires a login. It hits this URL, so which looks like this. And what I care about is I care about grabbing these particular data attributes. So repos, gists, followers, and following. Why? Because it's a demo. And I think we all can understand the simplicity of the data requirements here. And maybe I want to build an aggregation to see which of the users has the most public repos or the most followers and so on. So in my Python code to process each user, again, I use something called Python data series, the Pandas data series, and it's essentially individual record. If data frame is a table, then series is just one row. Okay, so I make a request to get this data. Again, have to pass the headers, process it. Then what I do is I loop through it and I grab only the keys that I care about. And then I'd say, okay, great, what do I do with it, right? Again, I made all these 310 requests. Now I have to store this data somewhere for future aggregation. And I'm going to use Redis as my database to store this data. Why? Because Redis has these very powerful data structures. In this case, I'm using Redis hashes using hmset command. And all I have to do is specify a key, which is a login, and a value, which is in this case is a hash map or dictionary of repos, gists, followers, and following. So let's jump into Redis via our CLI and see what's going on there. Oh, I'm also using Redis database 0 to store my data, and Redis database 1 to store the keys necessary for the background jobs. I don't have to do it, but it's just an easy way to namespace it and accidentally not step on my own toes. Okay, so I can see that there are 300 keys in my Redis database 0, which means all the jobs have completed. There's 300 users stored. Okay, let me blow it up a little bit so you guys can see. Okay, great. So now let's just see what they look like. I'm using hgetAll. Great. And I can also do a lookup at another user. Okay, so now I have 300 keys. So here comes one of the Redis's limitations. You can't query keys by anything other. You can't query the records by anything other than the key. I can't query by value. I can't say, give me all the users who have 50 public repos, etc. And this is where the data engineering part kind of stops and data science part begins. Right? This work would typically be done by a data engineer on your team. Well, data scientists come along and they say, great, I got this Jupyter notebook, and I'm going to write slightly different but very similar Python code. So first I'm going to create, import Pandas, create a Redis client. And now I'm going to, oops. So what is this code doing? We're grabbing all the keys. We're grabbing the value for each key as we're looping through them. We're modifying basically we're creating a new thing to add to our row. So again, in the Redis, our data structure looks like, again, the key is the login, and the hash map is the combination of repos, gist, and so on. But when we extract the data out, we want to take the login and put it back into the record, so to speak. So to do that, I just say, okay, value login equals key, and then I append it back to data frame. And actually, let's comment this out for now, just to see what it looks like. Okay, so I'm going to run this code. Okay, great. So you can see that this is just Jupyter printing things out. It doesn't want to show us all 300 records. We can see that there are 0 through 299. We can see that their logins were added. And if we want to manipulate this data a little bit to, let's say, find the sum of all, let's say, followers, right? So let's just not worry about this login for now. Right, so now I can use a data frame aggregation, df sum, and I'll run it. Of course, what happened? What the hell? Public repos, shoot. All right, let's not worry about this for a second. Okay, and what if we just print? I know what I need to do. There, worked. And now if I do, infinite, of course, because it's a string. So now if I do some massaging. So this is, again, something a data scientist would typically be doing. And hopefully it works. Great. So followers, we see total number of followers for all of the users. We see total number of following and so on. So we simply did a very simple aggregation in Python data frame. It's called df sum. And now we have the combined statistics. What are we going to do with these numbers? I have no idea, to be honest, but it is a demo. Hopefully, you guys can think of something that in your day-to-day jobs, you can say, oh, this is useful. Hopefully, you can go back to your work and say to your managers, hey, I think we can really simplify our data processing strategy aggregation using some Redis. Now, is this a right solution for like really, really big data problems? No, I don't think it is, because at that point, you're probably using something like Spark. You probably have a lot more capacity. But I think this could be a good solution for what I would call, medium data problems, right? Where you're doing more than just reading a handful of files from different places and then running something on your laptop or high-end desktop. This is where you don't have access to maybe some of the cloud resources. Well, hopefully you do. But you need something a little bit more robust, and you don't have time to invest in like a truly complex, enterprise-grade system. Okay, let's go back to the slides. So let's talk about the pros and cons to summarize it. By the way, if you guys have questions, just ask, because we have plenty of time. Or just shout out, raise your hand, whatever. Is there a question? Oh, come on, can you ask a question? All right, so what are the pros of this solution? Well, the nice thing is that we're using Redis as multi-purpose tool, right? We could have instead had a dedicated queue and a dedicated database, but here we're able to use it for both running our background jobs, and it'll handle all the, like the persistence of those things, and it'll actually snapshot things to disk in the background. So if we needed to, for some reason, stop our data gathering process, let's say we get a panic call from whoever's providing us the data, there's some kind of an error, we can just stop the process. All the jobs will be persisted in Redis, saved to disk, and later when we restart it, it's going to pick up right where we left off. We also have these cool flexible data structures with the Redis. Here we're using hashes, but we alternatively could have used lists or sets if that's what our aggregation needed. Like maybe we wanted to use a unique of something. So we could have just added a data to a set, and then would have guaranteed the uniqueness. And we also have speed. Data is persistent in RAM, so we can run these data processing pipelines pretty fast. The downside is RAM. In fact, here, the solution that I described you, we are really using a lot of RAM. We're using first Redis RAM to store the data, and then second, when we're extracting data out of Redis into this data frame, we're essentially doubling our RAM usage. So just be careful about that, and if you need to scale to something more than a laptop conference demo, use a dedicated server to run your Redis instance. And as I said, you cannot query by value. So this is where we could use a different database. For example, I've done a lot of work with NoSQL databases like MongoDB. We could have used MongoDB just to push those. Instead of doing a Redis HMSet command here, we could have created like a Mongo client and just pushed the data there, would have stored those documents in a collection, still had the flexibility, right? Because if we build a SQL table to store this data, it's actually really cool because we can just do group by aggregations right in SQL. But it means that for every different type of data source, we have to have a fairly well-defined SQL tables with columns, et cetera. And I've had to do that before NoSQL solutions came along, and it gets a little tiring. You have to write a lot of alter table queries because your data's format changed, and now you have to change. So, and alternatively, we also could have used large flat files, or basically instead of each record that we've queried from the user, we could have just saved it as a file, and then in our subsequent aggregation, we could have just read all these files into memory. It's possible, but I don't know, it just feels kind of cumbersome to have like hundreds and hundreds of files sitting around. But it is doable. So as I said, there are ways to do things without Redis. It's just that in this case, I think it's able to solve a variety of problems for us. It's fairly straightforward to use. There's a ton of libraries that work with it in a variety of languages and so on. Here's some useful links. Again, you will see them in the slide deck. And also, are there any questions? Yes?
Thanks, Dmitry. That was very
Sure.
interesting. I'm not sure as I understood it all, but
I'm happy to talk afterwards if you have questions.
yeah.
too.
Whenever you talk about looking up by value, I always think about Redis search. And then I saw you had some JSON in there. And I wondered about Redis JSON. I was just curious whether you considered those technologies as well as part of the solution, or whether you've thought about.
You mean like using Redis JSON module?
Mm.
Yeah, absolutely.
Redis
You could
search,
do
for
that.
example.
So, for example, if you look at this line, I'm doing HMSet, right? But what does my data look like at this point? It looks, it's essentially a simple one-dimensional hash. But if I had a more complex, multi-dimensional JSON tree, then yes, I could have installed the read.json module, and then in this line, I would have said save it as a JSON and then extracted it. If I don't have a JSON module, I would have had to probably just serialize it to a string and then save it as a regular Redis string. So. I'm sorry, what? Oh, you're talking about Redis search now? I've done some stuff with Redis search. I haven't done talks on it. It could be adapted, yeah. There's no reason why it can't be. I would say it's a slightly more advanced case. I was trying to keep this vanilla level. But yeah, again, anything you can do with Redis, you can do from a Jupyter notebook. Just write a little bit of Python code here to extract the data and do slightly different command. But you have to be able to install the modules, and you have to be able to install a Python client that supports Redis search, et cetera. Yes, Sharon?
Thanks, Dmitry. I'm Sharon with Citibank, and we have a particular use case right now that we're struggling with. The data scientists who are researchers use Jupyter notebooks and do a lot of querying of the data. We have a lot of text-based data for surveillance of communications. We process 2.6 million in near real time a day in 42 languages. So it's a massive scaling problem. But our DevOps team regularly has questions coming in from around the world as to why a particular data channel did not produce any results, or if a particular individual being surveilled did or did not have activity in the system. And we're struggling to find a way to quickly research cases that target very narrow data streams. The data science teams are trying to build tools to give to the DevOps people who are not necessarily as technical, that they can quickly run these queries in the raw data at the level of where it was ingested into the pipeline rather than the output of the case, because something didn't trigger or didn't create an output. Was it actually inputted at the front end? And so we need to trigger an investigation at the very start of ingesting data, and have a way to quickly query a lot of dirty data from 17 different sources globally. And so do you see tools like this as something where we can quickly prototype and grab them and build sets on top of a combination like Redis and Jupyter to hand off as utilities to solve DevOps problems, to do investigations into data sets to do quick queries and different methods of handling data analysis from a DevOps perspective.
Well, that's certainly a complex use case, so I'm not going to try to pretend to solve it here. But I think Redis could be used as a secondary tool for investigation. So just off the top of my head, I can think of basically setting up a Redis server, and as you're having your main pipeline, maybe some of the data gets pushed into the Redis, and you can use something like Redis Exploration to store it there for a period of time, let's say 24 hours. And then there could be a simple dashboard that allows users to query this data to see what the status of each job is, maybe, something like that. Alternatively, if you are DevOps, people are familiar with Redis and they're comfortable using the CLI tools, they could certainly log into directly in, like essentially what I did here, and run these commands. But again, the challenge is that I think DevOps people are often more comfortable with SQL, where they can like write a whole bunch of queries and join a whole bunch of tables. So
Maybe like query it, dump it in Redis,
Yeah.
and then manipulate it with the tools.
yeah, so so I think Itamar mentioned, I think, Ifta mentioned the Redis Insights tool. So yeah, so it could be used as a secondary storage to do some troubleshooting. Yeah, I mean, let's talk afterwards. I'll be happy to maybe make more specific suggestions. Are there any other questions? All right, I have 3 minutes left. So whoever's next, you can have 3 extra minutes. Maddie. Thank you so much. I'll be available afterwards for questions, so feel free to reach out to me or just feel free to ping me via Meetup. Okay.